Okay, so we're going to see a problem which is very important for this chapter, and you will face this kind of problems every now and then in every sort of exams. So we are asked to prove that root 2 is an irrational number. So how we going to prove this? We know the characteristics of rational number, we know the characteristics of irrational number, but here we're going to follow a reverse process. Like we're going to match it with the characteristics of rational number and see whether it matches or not. If it matches with the rational number, then definitely we call it irrational number. But if it doesn't match with the characteristics of rational number, we call it irrational number. So let's assume that root 2 is a rational number. Okay, so we are assuming that it's a rational number, and we are going to check with the characteristics of rational number whether it matches or not. So what is the first characteristics we know of a rational number? That we can represent 2q in the format of p by q, right? You can express it in this format where p and q will be mutually prime and q should be greater than 1. Okay, so we have talked about this earlier, the characteristics. Just we're going to check with these characteristics whether it matches or not. Okay, so let's say root 2 is equal to p by q. So let's remove the root over here. Okay, so squaring both sides, we can remove the root. Okay, 2 is equal to p squared by q squared. Okay, so let's multiply q on both sides. So what do we get if we multiply q on both sides? 2q is equal to p squared by q. Okay, so let's just check this side, 2q. So 2 is an integer number, right? And q is, remember this condition, q should be mutually prime and should be greater than 1. So q is also an integer. So if you multiply an integer with an integer, what do you get? Say this thing, integer into integer, we get another integer. So this 2q gives us an integer value. Okay, so now let's see, we are talking that 2q is equal to p squared by q. So let's see whether p squared by q is also an integer or not. Okay, so we see that this whole thing, p squared by q, it's in a fractional form. Okay, like if you consider any value of p, say we're writing 3. Okay, say we're writing 3 squared, and let's say we have the value of q, which is 2. Okay, remember p and q are mutually prime, right? There are no common factors between these two. So these two are mutually prime, and when you putting in this format, we get a fractional value. So this will never be an integer. It will not be an integer. Okay, so it gives us a fractional value, like 9 by 2 is equal to 4.5. So check this condition over here. Here we say that 2q is an integer and p squared by q is a non-integer. It's not an integer. Let's just keep it on the other side. This is a non-integer. So can we say that this integer is equal to this p squared by 2? So we can not say that these are equal. So 2q is not equal to p squared by q. This is not equal to this. Okay. So that means that we cannot root 2 cannot be expressed in P by Q form. Okay, so according to the characteristics of a rational number, we know that it should be expressed in P by Q form, but root 2 cannot be expressed in P by Q form. So that means this is not a rational number. So if it's not a rational number, what we can say? Root 2 is an irrational number. So this is how we have just proved that root 2 is not an rational number. So remember the process. The first step we have done. Need this anymore. So just see the first step. We're assuming that root 2 is a rational number. Then we're going to check with the characteristics of a rational number whether it matches or not. So we have put it in this form, P by Q form. Then after calculation, we see that one side we have an integer value, another side we have a fractional value. So it doesn't, both sides doesn't match, are not equal. So if these two sides are not equal, we cannot put it into the form of P by Q. Okay, so that's why we are saying that this is not a rational number. Any number which cannot be, we cannot put in P by Q format is not a rational number. Okay, so root 2 cannot be expressed in P by Q form, so it's a irrational number. So we have just proved that root 2 is a irrational number. So it can be any number given in your exam, like root 5 or root 7 or root 11. You're going to follow the same process. The process will be same. We're just going to assume at first, and then we're going to do the rest of the calculation. If our calculation is right, we're able to prove that these are irrational numbers. So this is what it is.